Hey, it's Mr. Barr. This is the Math 1 Stats pre-test. Second time we're doing the stats in this class, but this is specifically for Math 1. Here's question number 1. I've actually already taken this thing, so you're going to see my correct answers. Looking at this line, it looks pretty good to me. Correct answer is B. The line, it's a good fit because it kind of matches the data. A isn't correct, although it says it's adequate. It's not adequate just because it goes through one point. It's adequate because it really matches the data. Okay, question number 2. I've got this set of data, and what I'm going to do, oh, my lights just went out. Let me turn them back on. All right, so what I did is, first off, question number 2, I listed out the data, and then I actually put it in order. And then I broke it into the intervals that it wanted. It wanted intervals of 10. So I went with the 10s, the 20s, the 30s, and the 40s. And then I turned it into a bar graph. And it looked like this one with 4 in the 10 region, 1 in the 20 region, 4 in the 30 region, and 1 in the 40 region. This is question number 3. Looking at box and whisker plots. So I started by listing out all the data for it, boom, 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 and found the minimum, the first quartile, the median, the third quartile, and the maximum. And then I just took that and matched it up with the graphs, and it matched up with letter D. B. B is the only line that fits that data, so the answer is B. Question 5. This one, you're going to start with drawing a best fit line. So let's draw a line. You know what? I don't like that point. I don't like my starting point. Let's try a different one. Let's go with this. How's that for a best fit line? Some higher and some. That's a good best fit line. Once I have a good best fit line, oops, I can use the best fit line to draw a slope triangle. There we go. Look at the rise of that. Let me go to the page. If you look at the rise, there we go. It's going up by thousands, so it actually has a rise of 10,000 and a run of 4,000. So 10,000 over 4,000 is 2.5. So there's my slope, and comes down here, and the intercept is at 10,000. Notice everything's in thousands. So my equation is y equals 2.5x plus 10,000. Y equals 2.5x plus 10,000. Nope, I'm still... clear all. Going to the next question. Okay, we want to create the best fit line for this and the equation for it. So let's draw on a line. Let's see, how does this do right there? That looks pretty good. Actually, looks really good. And then we'll find the slope of it. Okay, so this is going up by 2, so it has a rise of 2 right there, a rise of 2, and a run of 3. So my slope is 2/3, has an intercept at 4. There's the 4. So I have y equals 2/3 x plus 4, but the problem is the graph is set up with h and, what's the other variable? I think a's. So you've got to convert it to h equals 2/3 a plus 4, which is what I have. H equals 2/3 a plus 4. Next one, number 7. So I have these two sets of data. So first off, I put my data here. I found my mean. My mean was 20.25. My median is 24, and my interquartile range is 21. Found that for set A. Set B did the same thing, have a mean of 21.25, a median of 24, and an interquartile range of 24 also. Then it was a matter of matching it up. This one is the only one that matches. It says set A has a smaller mean. Set A, it does have a smaller mean, and it has the same median. So I matched it up. This one, I took all that data from the table, and I wrote it out. So I have 4 1-year-olds, 4 8-year-olds, 5 3-year-olds, 7 4-year-olds, 8 5-year-olds, and 9 6-year-olds. So I just wrote out all those numbers, And then I added all the numbers together and divided by 37 because there were 37 numbers or 37 kids in this set. And I get a median, not a median, a mean of 4.03. And then I found the middle value. I just counted. There are 37, so the middle is at 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's the median at 4. So those are my answers. If you round it incorrectly, you're going to get it wrong. And finally, we've got a normal distribution thing going on here. So I drew a normal curve. It told us that the mean is 320 and the standard deviation is 23. So I went up by 23, up by 23. Also went down by 23. And that gives me the numbers we were looking for. You can't see it on my screen, but over here it said, hey, what percent are between 297 and 366? So right here, this is 30. I'll use this table here. 34, 34, and 13.5, which adds up to an 81.5%. And that's the video, and thank you for watching.